In these two word problems, what we're going to do is set up a system of equations to solve the system. Now, in these two examples, I believe in this first one, we're not going to actually solve, but in the second one we will. So I just kind of want to work through just the challenges of putting together the equations before you would actually solve them. So this question says that Mickey is deciding between two cell phone plans. Now the first plan, so we're going to write an equation for this first plan, has a $50 sign-up fee, and then it costs $20 per month. And then it says there's a second plan, so we're going to write an equation for that. That second plan has a $30 sign-up fee, and then it costs $25 per month. It says write a system of equations that can be used to determine how many months that the cell phone plans will be equal, and let X represent the number of months, and Y will represent the total cost. Now there are three types of linear equations that you can use to work with. One of them is called y equals mx plus b, and this one will have what is called a starting point. Usually we call it a starting point. Sometimes you'll call it a y-intercept, and then you'll know a slope. Another type of linear equation is y minus y1 equals m, your slope, times in parentheses x minus x1. Now in order to use this, you need to know three things. You need to know an x value of your point, a y value of your point, so you need to know 1 point, and then you need to know slope. And then the last equation is called ax plus by equal to c. And so what you really have to do is decide which of these equations you need to be able to set up your system. And so that's what makes these problems just a little bit more challenging than just solving. So if I'm looking at what I know here, I know a starting point and I know a cost per month. So I know two things to plug into my function. Now, if I'm just kind of using process of elimination, in order to use point slope form, I have to fill in three things: my x1, my y1, and my m. So I know I can't use this function because I'm only given two numbers, 50 and 20. And then in the third type of function, the standard form, I need to know an a, b, and a c. Again, needing to know three things means I'm not going to be able to use this function because I don't have three numbers, I only have two. So I know the type of function I have to use is my slope-intercept form, y equals mx plus b. So we need to know our rate of change, and you normally can see that rate of change with the word per, so I know that $20 is going to represent my slope, and then the b is going to be your starting point. So for my first plan, my startup fee is my starting value, my starting cost, and then my slope is going to be the 20. So $20 per month plus an initial $50 sign-up fee. And then here's my second equation. Y equals $25 per month, so a little bit more, but your original sign-up fee is a little bit less, it's $30. And so that would be our two systems to work with or two equations for the system. Now, in the next question, it says we're actually going to solve. So take a look here. It says, Andrew is 25 years younger than Lori. The sum of their ages is 61. Write a system of equations that can be used to determine Andrew's and Lori's age. So now they're actually asking us to solve. What is Andrew's age in years? So I'm going to first define my variables. I'm going to let A represent the age of Andrew. And I'm going to let capital L equal the age of Lori. So here are going to be my two equations. The first sentence I'm going to write as an equation. Andrew is 25 years younger than Lori. So Andrew, for A, is means equal sign. Andrew is 25 years younger than Lori, meaning Lori's age minus 25. So if we take Lori's age and subtract 25 because he's younger, we'll get Andrew's age. Then it says the sum of their ages. So that means we're going to add them together. Andrew plus Lori, the sum of their ages is 61. Now this system that we have here, our two equations, are actually set up for substitution right away because I have my A solved for in my first function. So what I'm going to do is take this expression and sub it in the A of the other equation. So instead of Andrew plus Lori, I'm going to sub in this expression in place of Andrew here. So Lori minus 25 plus Lori will equal then 61. Now I'm going to remove my parentheses and solve for my L. So L minus 25 plus L is equal to 61. Well, I have an L here and an L here, so total I have 2 L's on this side. Minus 25 is equal to 61. Now if I'm going to solve for my L, I need to add 25 over to the right side to get my L all alone. So 61 plus 25 is going to give me 86. So 2 L's equal 86. And now if I'm going to solve for my L, all I'm going to do is divide by 2. So Lori is 43. Now if the sum of their years was 61, if I plug in here 43, the sum of 43, and then Andrew's age is 61, I can solve for Andrew by subtracting 43. So Andrew is, let's see, 61 minus 43 is a total of 18. So Andrew would be 18. Now I just want to read what we had from the beginning real quick. Andrew is younger than Lori. That makes complete sense because Andrew's age is smaller than Lori. So then I'm just going to double check. Is Andrew really 25 years younger? Is 43 minus 25 years younger 18? Yes, it is. So you just kind of double checked. And that's it.